Welcome back to part 2 of the jeweler's drawer sweeps, refining and recovery. This is our gold button that we got from part 1. What I'm going to do is I'm going to put it down here inside this beaker, and what we'll do is I've got some hydrochloric acid, and I'm going to add about 300 milliliters hydrochloric acid. I've got some nitric acid, and what we'll do is measure out about 75 milliliters of nitric acid. This is way more nitric than I need. We're going to add it right on in. 300 milliliters of hydrochloric and about 75 milliliters of nitric acid. That's only 28.4 grams of gold in there. And so I can usually dissolve that much gold, if it was in powdered form, with about 10 milliliters of nitric acid. But since it's metallic form like that down in there, it's going to take a lot more acid, nitric acid, to dissolve that thing. I could have melted it and poured it in chunks in water, but the effect of watching the gold button dissolve in the aqua regia is much more dramatic by just leaving it in this form. Anyway, I've got way more nitric in there than I need to ensure that the button goes into solution completely, and then we'll just boil it down to drive off the excess nitric. Now we'll add some heat, and let's put this gold button in solution and refine it to high purity. This is the entire dissolve sequence. I add the gold, I add the hydrochloric acid, and then I add the nitric acid. And like I said before I started this, that's way more nitric than I need to dissolve that amount of gold. But it's in solid form, so I used a whole bunch of excess nitric in order to go ahead and get this gold button to dissolve completely. Now, this is going to be an example of the classic evaporation down to a syrup to drive off the excess nitric acid that's in that solution. This is the best way to get rid of excess nitric acid. Adding urea or any other reagent to drive off excess nitric is just, that's not the way to do it. This is the best way that I've found in my practice. It takes longer, but that's okay. We patiently wait, and we give it the time it needs to get rid of all the excess nitric out of that solution. We've had this evaporating for about an hour. You can see we've got it all the way down to a syrup. There's probably less than 20 milliliters of solution in there. And so we're still cranking out lots of fumes, which means we've got nitric to still, we got to rid this solution of this nitric. So I'm going to add some hydrochloric acid, rehydrate the solution with hydrochloric acid, and now we're going to boil it down one more time until all those fumes go away. We've got it evaporated down again. All the fumes are gone in there. If you remember earlier when we evaporated it to this state, it was full of fumes. Those fumes are gone now, so it's safe to conclude that our solution is free of nitric acid. I've got some hydrochloric acid here. We're going to rehydrate the solution now with some hydrochloric acid. I've got some sulfuric acid. I'm going to add in a few drops of this, just in case we've got any lead in here. It's been allowed to cool for a few minutes. Now what we're going to do is add some ice to cool it down, dilute it further, and to precipitate out any silver chloride that may be present. Got this thing chilled down pretty good now. So what we'll do is filter out the junk that's in there. There is some junk. Remember, this was a button that we recovered in part 1, and we didn't refine it. We just pulled the silver and the base metals out with dilute nitric acid. This is the trash that was left in the gold after we did the recovery with hot dilute nitric acid. You can see up in the beaker here, there's a little bit of solid material. This is all the trash that we've got in our filter. Got everything filtered now. Let's go ahead and pull our filter out of here. Or funnel rather. Get it out of the way. Now we'll transfer our gold bearing solution to this beaker. Let's go ahead, precipitate out the pure gold with some stump out. This is always the best part, the funnest part. We know there's no nitric in there, so we should not have any problems with excess nitric, because we've seen it all come out when we evaporated this down to a syrup. Should just about do it right there. It's been allowed to settle completely. What we're going to do is, it's got a yellow tint to it. I'm going to test it with Stannis. And as you can see by that negative Stannis test, there's no precious metals in solution. I did see some steel pieces in there when we were doing the, when we were dissolving. So there may have been a few pieces of steel in there. You can see that the test has turned slightly just a little bit of a color to it. Could be some platinum group metals in there. What I was trying to say is it's iron. The color is probably from the iron, from those steel pieces that dissolved in the aqua regia when we were dissolving the gold. Now let's pour off this waste solution and rinse the gold off. Alright, we're going to take the gold, boil it in some hydrochloric acid. It's been boiling in the hydrochloric acid now for a few minutes. What we'll do is take this and we're going to pour off this waste solution. And here's what our gold looks like down in the bottom of the beaker after the first refining. We're going to begin this second refining by adding some hydrochloric acid, about 100 milliliters. And now what we'll do is we'll set this up on the heat. And now I'll add a little bit of sulfuric acid, just in case there's any lead in there. Just a little bit, not much. And now I'm going to go with three 3-milliliter doses of nitric acid. 1, 2, 3. And this should be enough nitric acid to put all that gold in solution. I've got all the gold to go into solution. That took about 5-6 minutes. So now what we'll do is we're going to boil this down and until all of the fumes disappear in there, to ensure that we've ridded this solution of all the excess nitric acid that may be present. Look at the chloroauric acid solution. People have asked what would happen if we evaporated it down to dryness, and there you see it. Those are crystals of chloroauric acid, solid chloroauric acid crystals. So that's what would happen. You could evaporate this down completely and then gather those crystals up and put them in a bottle and store your gold in crystal form indefinitely. What I'll do now is add some hydrochloric acid, and we're going to rehydrate this and put these crystals back in solution. Give it a little swirl here, and all of the solid crystals will dissolve completely in that hydrochloric acid. These ice cubes are made from tap water. Here we go. I've got a clean beaker. Here's our funnel. Looks good. I add that paper to my paper storage. Let's add the gold solution to a clean beaker. Got a nice clear and bright solution. So now let's go ahead and precipitate out the pure gold with some stump out. Here we go. Here's our next spoon of sodium metabisulfite, aka stump out. Spoon number 3. And this is number 4. This should do it for us. Spoon number 4 of the stump out. Gold has been allowed to settle completely. Now what we'll do is get rid of this waste solution. Now we're going to add some hydrochloric acid to the gold. Cover it up. Put it up here on the heat and give it a boil in hydrochloric acid. While I'm waiting for that gold to boil, what I need to do is empty out my waste container into my stock pot. My stack pat is full of copper in here. And what we do is we empty our waste solution into the stack pat. And then any precious metals in this solution that I'm pouring off will cement out on the copper and settle to the bottom of the stock pot as a black powder. This is the first step in the waste treatment process to extract all the precious metals out of this waste solution, if there is any, onto those pieces of copper in there. Now I'll cover this up and we'll set it outdoors and let it react. All right, let's get this gold out of this boiling acid now. Here we go. Let's get this gold into a melt dish. All right, I believe that we are ready now to melt this up. A little ingot out of this. Here we go. Okay, here's our gold bar. It's got a little bit of flux on it. So what we're going to do is put it in this beaker. And I'll add some water. And then what we'll do is add a shot of sulfuric acid, a couple of milliliters. And we'll turn some heat on. And that should take that flux off of that bar for us. Alright, I think we've got all the flux off of there. Take this in, rinse it off. Here's our bar that we just melted. Don't look too bad. It's still got some trash in it. And we'll probably end up refining it again electrolytically in the electrolytic cell. See what we have, 28.4. We got 26.6. So we lost a couple grams during the refining. And then for part 3 of the series, what we'll do is I've still got these solids. You can see there's a layer of fine gold particles down on the bottom of that beaker. We're going to go after that in part 3. So I guess this will conclude part 2 of the jeweler's drawer sweeps, refining and recovery videos. Thank you for watching.